All right, so delighted to have you here this morning. And I know a couple more people will be coming in, but I'll just start with a little bit of an introduction so that to appreciate the fact that you are here already now and not to wait for other people. So this is the second webinar in this series on uncertainty and discomfort, or certainty and comfort, or any combination thereof that fits or that interests you. And this is something that I'm quite interested in, and I have been finding lots of other people that are looking at these ideas and these concerns from different perspectives and looking at the potential vehicle of discomfort, because we know that learning is an effortful process for learning, and particularly around questions of certainty and things being absolute, absolutely true, absolutely right. That absoluteness, which is really attractive to us, but is rarely really authentic. And so encouraging people to get into that space more. So this is the second webinar in this little series here. And specifically, so this is coming from Ina, our presenter. In this session, we're going to be looking at, Ina will be telling us ideas about how to trigger competency development in students, and looking at why traditional teaching might not be developing those key competencies that we need in our students, and also an opportunity a little bit to connect with other teachers and researchers who are interested in some of these same questions as yourself. So as a very small warm-up, I'm going to suggest that you open up the little chat window, and that don't hit send yet, but in that little chat window, type number 1 and answer the question about the types of uncertainty that your students currently struggle with. Without hitting enter, you can put in the number 2. And what kinds of uncertainty would you like your students to be encountering in your teaching? So don't hit enter yet. Hold on to those. I'm going to give you 3 minutes to work on that, and then then I'll give you a separate prompt for sharing. So just write in the chat, don't share yet.
Is it just me who can't write in the chat?
So that we have had this problem.
It's not just you.
It's not
actually.
just you. But so let me just try here. So I can write in the chat. I don't know. I'm hoping that I'm not the only one.
No, I can't write in it either.
I can write in the chat perfectly. So I don't know.
So I see that
mine's working.
Some people appear as external, and some people appear as unverified. And I think that if you're unverified, you may not be able to write in the chat. I don't know.
That chat is only available during the meeting, but I cannot write anything.
All right, well, I'm going to encourage those people who were able to write in the chat to send that. And if anyone else would like to verbally share their feedback, that their questions, their types of uncertainty verbally, then we'll take 2 minutes to do that. So if you want to raise your little hand, if you've got some uncertainty that you'd like to share. Any single words here? What types of uncertainty do your students struggle with? Mm. Excellent. These are really interesting topics, and I'm really interested to hear more about how these interact with what Ina's going to share with us today. So I'm going to move forward here to introducing, well, I won't introduce Ina much, but just her topic here of triggering ethics, competency development, and engineering students by integrating irritation as a didactical principle. I had the privilege of actually seeing Ina's presentation at SEFI, and I could tell already from the description in the conference program that I was interested in this topic, and I was so interested in her session and in the approach that she's taking of creating, I think, a really rich learning opportunity for her students. It was what I think it was maybe the very last presentation, and there was like all this stuff to run off to. But I said to Ina, I'm going to be back in touch, and so I'm so happy to be able to hear from Ina now, a number of months later, and hear how that's continued to develop for her, and to have this forum to get to share it with all of you who are obviously interested in this, who have joined us here today. So Ina, I will stop sharing here and turn over to you.
Ina, I think you're on mute.
You are muted.
Sorry. Yeah, I already said thank you very much for having me here, everyone also attending. There are quite more people in here than I'd expected. Yeah, we had great discussions at the SEFI about this topic already, and I'm very, very happy to talk to you and with you today about triggering ethics competency development in engineering students by integrating irritation as a didactical principle. But first of all, I need to know, do you see my slides?
Yeah.
Yes.
Okay. Perfect.
Yes, we do.
Okay, great. Thank you very much for letting me know. So my name is Ina. I work at the Berlin Ethics Lab at TU Berlin. I'm a social scientist working nowadays among mainly philosophers. And for the last 12 years, I've been working among engineers. So I'm at this cross-section of engineering, philosophy, ethics, and all this from an educational perspective. So this might probably explain my perspective on our topic today as well a little bit. As we all know, I have to start a little early in my narrative. We all know mankind, or I'm sorry, I'm not sure. You're seeing my slides, right? Because this looks strange to me here.
Yes, we see them.
Okay,
Yeah,
great.
it's good.
We see your slides.
Perfect. Okay, thank you. I don't know what's going on with my screen, but doesn't matter. We just go on. So we all, as a global society, we are facing severe problems, as we all know, connected to the sustainability crisis. So in this poly crisis, every one of us plays a role, either as a contributor to the crisis or as a contributor to the solution. And I guess actually most of us play a double role in there. However, if we want to see a future evolve that is worth living, we need to strengthen the contributor role in our society. And a key target group for that are engineers. Why is that? Well, we have some numbers to tell us that the engineering sector and the engineers themselves play a considerable role in making changes to our development path. Those numbers are for Germany, but of course they also apply to many other countries in a similar way. But apart from these numbers, we live in a techno society, and almost everything we do involves some kind of technology. And the way that these technologies are designed makes a huge difference to our sustainable development path. So, and who has a key role in designing technologies? Of course, engineers. However, their role in this process has changed over the last decades. So technology development has always been a somewhat interdisciplinary matter. But how the processes and the values used to be centered more around the engineering perspective on the world, which is a very specific perspective, actually, focusing on categories such as efficiency, for example, while probably rather ignoring categories such as fairness or equity or other ethical categories. Responsible technology design, in the sense of technology assessment, is nowadays considered to be dependent on inter- and transdisciplinary processes in which the engineering perspective is just one among a variety of perspectives. So this is what we actually need to prepare our students for if they're supposed to become contributors, not to the problem, of course, but to the solution of sustainable development. So we can see in this picture, like this is a very abstract display, but in the beginning, in the left picture, we have the engineering perspective pretty much in the center, surrounded by similar but not equal perspectives of other related disciplines. Then we came into this broad interdisciplinarity for integrated academic solution development. So that was a phase where we had a bigger academic integration. And nowadays, the brown one has shifted from the center to the side. And nowadays, there are even much more stakeholders in there as we are looking for transdisciplinary processes for responsible technology design. So the role has changed quite a lot, but our teaching has not changed in the same intensity. So, but what does it take to prepare our students for this? I think everyone in the teaching field will have come across the concept of competencies. This is often used synonymously with the term skills in English literature, I think. I've also seen in the chat someone asking what's the difference. I can only say that for the German discourse, in Germany, we delineate those two terms, skills and competencies, very strictly, because skills are something that you are able to do by training. And a competency is a much broader concept that also includes skills, but it's not the same. I think the discourses are there a little bit different in different cultures. So the UNESCO, among many other institutions, define competencies as a combination of knowledge, skills, values, and attitudes, as we do also in our German discourse, that enable individuals to act effectively in different contexts. The traditional understanding of education is thus expanded to include the categories of values and attitudes, because our formal educational system mainly focuses on knowledge acquisition and skills development. But those other elements that are actually necessary to act effectively are a little harder to approach in education. So these more diffuse elements of the competency concept, they are quite hard for educational practitioners because they cannot be taught directly. They are constitutive elements of a person's personality, and as such, they are usually strongly treasured and also protected by that person. So they are not really open for negotiation. However, only if those values and attitudes are in line with the idea of sustainable development, our students will apply their knowledge and their skills in a favorable way. So we cannot ignore this. So I thought we should have a look at the competencies that might be important for educating engineers for responsible technology design at this point from our perspective at the Berlin Ethics Lab. But first of all, I would like to reframe the term of those competencies, because in the title of my talk, I called it ethics competencies, which is very short and nice, but to be more precise, we should rather go for the longer term, which would be competencies for ethical decision-making in our context in technology design. This is because it is not competencies for moving in the philosophical field of ethics that engineers need. We don't need to make them philosophers to make ethically based decisions. What they need is competencies that enable them to participate in such decision-making processes on an ethical basis. So This is also a reason we've heard at the SEFI several times, or I've read SEFI papers about it, that people tried to give their students in their first year, their engineering students, classes on classical philosophy and ethics. But then somehow this didn't really have an impact on the mindset the students developed afterwards. And I guess this is part of the problem, because they don't need philosophical or ethical competencies. They need competencies to act ethically, which is a difference. So as I said before, responsible technology development must build upon inter and transdisciplinary technology assessment. If you've been to my speech at SEFI, you know those slides already. This kind of assessment requires certain competencies. First of all, the competency for knowledge integration, since of course knowledge integration is what inter and transdisciplinarity is all about. This competency again is constituted, among others, by the competency for interpersonal relations and collaboration, as well as the competency for interdisciplinary work. If you're interested in more detail, I've put the sources next to it for you, because I think this would be much to talk about today. Those two competencies, interpersonal relations and interdisciplinary work, they in turn require the competency for change of perspective. And the prerequisite for this competency of change of perspective is an appreciative attitude for diversity of perspectives. You see, without this appreciation for diversity and for different perspectives, none of the above elements actually can evolve. Unfortunately, all this collides a little bit with the dominant engineering culture into which engineering students are socialized during their studies. Let's have a look at that. The dominant culture in engineering education, although it is certainly shifting, and it's only the dominant one, there are other subcultures, certainly. But the dominant culture strongly builds upon the traditional understanding of learning, like which conveys implicit messages that are actually contradictory to many of the competencies we want engineering students to develop. These messages are part of the institutional history of formal education. Many of them represent values of a bygone era, which are often passed on unnoticed through institutional routines, through the way relationships are structured in those institutions, and so on. This already starts at school, or in many countries at kindergarten level. And in school, these can be, for example, messages of competition, although we actually want people to learn to collaborate, especially in the context of sustainable development. There are messages that promote mere reproduction of knowledge instead of innovative and creative thinking, which is, of course, what we would actually love to see for problem solving in this context of sustainable development, and many others as well. And there are messages that put different perspectives, for example, disciplinary perspectives, into a hierarchy. A very simple example for that is if you have a look at a timetable at school, you see how many hours a week are allocated to which subject, and which are major classes and minor classes, and so on. While some disciplines are apt to break with those obstructive messages at the university level, engineering programs tend to even reinforce them. For example, by assuming engineering to be objective and rational, which construct engineering sciences as inaccessible to broader social issues and demands. That was too quick. So this is one example. The same goes for splitting of emotions, which are a core requirement for empathy and change of perspective, which, as I just said, engineers need in inter and transdisciplinary technology development. So obviously, preparing future engineers for contributing to responsible technology design, we need to break with some cultural norms of engineering, which are reflected in engineers' epistemic attitudes and assumptions, and their worldview, actually. So how to do this? how to trigger the more personality-related aspects of competency development in engineering students in order to foster an appreciative attitude towards perspective diversity. We know from psychology that people only fundamentally adapt their views when they experience an irritation of their existing perspective, so that those perspectives or views are actually challenged. As long as they work, they won't touch them. Since literature also shows us that such irritation of their views occurs through conflict and confrontation with other perspectives, or also with disruptions of routines, it should be possible to deliberately stage moments of irritation in the classroom, we thought, in order to expose our learners to a pressure of change. Therefore, we decided to design a course that was set to irritate the disciplinary and the academic attitudes and assumptions of engineering students. So this was an experimental design. And this was based on two hypotheses. The first one was that broad interdisciplinary collaboration irritates the disciplinary framework of reasoning and thinking of our students, and thus leads to an increase of engineering students' appreciation for other disciplinary perspectives. So here we are in the interdisciplinary field. The second one was that transdisciplinary collaboration irritates the academic conception of knowledge and thus leads to an increase of engineering students' appreciation for non-academic perspectives. So just to make sure we are all on the same page here, interdisciplinary means that people from different academic disciplines work together, bring in their specific perspectives to create a shared picture or a concept of something, or a shared approach to a certain problem. Multidisciplinarity would be that each one can contribute their own perspective, but they are set side by side. Interdisciplinary means they have to be integrated somehow. Transdisciplinary means we are leaving the academic sector and we are actually working together with people from other fields, from politics, economies, civil movements, whatever. So whoever is there as a stakeholder could be invited to take part. Our design looked like this, our course design. So in the upper section, you have the course phase, and in the lower section, how we collected data. We started with the ID, as the interdisciplinary phase, where our students worked in broadly interdisciplinary teams. So 50% of the students we accepted were engineers, 50% were from all kinds of disciplines, philosophy, architecture, social sciences, and so on. And together they were to develop a research question or identify a problem field from sustainable and fair urban mobility, which they wanted to work on transdisciplinarily in the end. But first, as an interdisciplinary task, they had to find this problem, they had to define it, and they had to develop an initial research design. Initial because in transdisciplinary research, of course, this design is open for reconsideration if your co-researchers from the other academic field think this appropriate. After that, there was Stimulus 2, that was the transdisciplinary part, where they actually went into their research collaboration with outer academic stakeholders. During our first part, the Stimulus 1 phase, we asked our students to write reflection papers, one very early in this process and one in the end of this process, when they had come to a shared vision of their problem. And we asked them to write a third one in the end of Stimulus 2, like the transdisciplinary research collaboration. Furthermore, we did a survey with our students in the end, a self-assessment survey, and we had a group discussion in which we took part as participant observation researchers. So we were there, we were part of the group, but we didn't engage much into the discussion. We asked our students to share their experience, share their thoughts, their learnings, and come up with shared statements that they could agree upon. Apart from that, we integrated many further irritations to our students' study routines in order to amplify the irritational effect. We wanted really to break with their study norms, to open up their minds for different perspectives. So first of all, we broke with the classical hierarchy in teaching by staging ourselves as much as possible like fellows to the students, not as teachers, merging with them, being part of discussions instead of leading them, and so on. We also broke with the spatial routines of academic learning. So every time our students' presentations referred to the public or outer academic fields, which was frequently the case, depending on, of course, on the tasks they had to do, they had to present this in a public space. So the public would be able to listen or engage if it wanted to, which makes quite a difference in the way you present, actually, if those people you're talking about are listening. We also broke with media routines, since in this public space, the students had to come up with other visualization ideas than PowerPoint slides, which is usually what they always do in our courses at TU Berlin. So they got quite creative. Many used flip charts. Some built own constructions for posters. The architecture students were very creative there. Some worked with web pages they created and brought a QR code on little cubes, which we could all take a picture of and then follow. So there were many different ideas, and they worked a lot with prototypes as well. It was very nice. They really got creative over time. Another thing we did was we broke with learning routines by turning almost all our content input into a podcast format, in which we interviewed international experts on the respective topics, which also helped breaking with our teacher's role as being a single source of unquestionable truth. So we actually constructed ourselves as co-learners together with our students, and we never said we know how transdisciplinarity works. We always said, hey, let's find out how it works. Let's ask people who do this, have done this for many, many years. And this had quite a great effect on the students as well. I guess many mentioned that in the final discussion that they liked this very much. And finally, we put all emphasis on the learning process, not the project outcome, thus valuing reflection over actual project results. So we underpinned this by attributing very little importance to the grading of the students. And as a matter of principle, we assess their willingness to reflect rather than the project results and rather than their reflection content, because you cannot grade. Okay, I've got an echo here. Someone turned on some mic, I guess. Yeah, but you cannot grade a reflection, actually. So we really, really discouraged thinking about marks or grades. So what did we find? First, we analyzed the reflection papers. It is very important to note here that this is not a ratio scale. What we did was we defined 6 different tolerance levels for diversity of perspective, which we allocated the students to. We had 6 levels from no acceptance at all up to thinking transdisciplinary perspectives are utterly important. And depending on certain words or descriptions of the students, we allocated them to one or another of 6 categories. And in the left graph, you find each student, and in the right one, this is the one I want to highlight here, there are the summarized results. So we see in the left one, there's quite a difference, but in the end, they're pretty similar. In the beginning, they vary a little bit. But yeah, the 2 interesting things we found was first at T1, that was when they wrote their first reflection paper, pretty early in our course, the students started with quite a high level of tolerance for perspective diversity already, which was somewhere in between appreciating interdisciplinary perspectives and thinking they were really important. The second thing is, while this tolerance even increased over the interdisciplinary collaboration between T1 and T2, it increased much more over the transdisciplinary working phase between T2 and T3, ending with a perceived necessity to involve inter and transdisciplinary perspectives almost in general. The next was the quantitative evaluation of our self-assessment survey. And here we can see that the students judged their, here we call it skills, because competency is not a word they usually work with, their skills to act in inter and transdisciplinary settings almost equal in the end, both very close to rather strong, 4, that's a category in here. However, the path they felt they had taken was much longer for the transdisciplinary than for the interdisciplinary field. So we can see, as I said before, so this reflects actually what we found in their reflection papers, that they started with, according to their self-assessment, moderately strong interdisciplinary skills already. And then they went up to rather strong. While with transdisciplinary skills, they started somewhere in between non-existent and rather low, and they went up to moderately strong, closer even to rather strong. So the development in there was much greater. So last, I would like to share with you the results from the group discussion. So we had asked our students, as I said before, to come up with shared statements. And interestingly, most of them did not depend on discipline. So all our students, like the one from engineering and the others, they all agreed on a statement that said research questions whose outcome affect broader sections of society profit greatly from inter and transdisciplinary diversity of perspectives, which is lovely because, of course, it's a good foundation for inter and transdisciplinary work to think this is important. Then 50% of our students, mixed engineering and non-engineering, said the inter and especially the transdisciplinary experience changed my entire perspective on science and academia. So exactly, I mean, this is actually what we'd love to see. There was a real change in attitudes or in yeah, not values, rather in a perspective on academia and on science. And by the way, the other 50% didn't say it didn't change anything. They just didn't agree to it changed their entire experience or their entire perspective. They didn't want to agree to that. They said it did change it, but not entirely. Then all students also agreed on there were moments of strong irritation and feelings of severe disorientation when collaborating with people from other fields, especially outside academia. However, this changed to confidence and powerful enrichment after a while. So this, of course, is beautiful because this is what we were looking for or what we wanted to check. And they framed this themselves. We see the development in here. First, the strong irritation and the feeling of severe disorientation due to the stimulus of different perspectives, followed by feelings of confidence and powerful enrichment, like, yeah, actually, this is about self-efficiency, I guess. And the last statement I want to share with you is only from the engineering students. Interestingly, they brought this up and the others did not want to agree, but all the engineering students finally agreed on this course was a very rare chance, or a rare chance to be precise. We would have never considered this, meaning inter and non-academic perspectives, within our usual disciplinary studies. So this shows that for the engineering students especially, this was a very new and very important input they gained there. To wrap up what we found, the students started with a higher appreciation for interdisciplinary diversity of perspectives than we had expected, which is probably not that surprising if you come to think about it, because we were a free election force. So people came who were already interested in doing that. Each stimulus was followed by a phase of irritation and eventually by an increase of appreciation for diverse perspectives. This effect was much stronger for transdisciplinary than for interdisciplinary diversity of perspectives, which gives reason to believe that students probably are already a little accustomed to working interdisciplinarily in our education at Berlin, which would be nice to believe. But transdisciplinarity, this is very rare. And the effects could be shown for all participants. However, to the engineering students, this was especially important. And last, we concluded irritation-oriented course design is a promising approach for provoking competence development in students. So we are going to go on researching this. We had a second semester now running through this, finding new problems, finding new insights, but we have not evaluated that yet completely, so I cannot share yet with you. But there's going to be a SEFI paper on that. So I would like to share last few thoughts with you that came up during the course, although they were not part of our research question. Well, it is a very sensitive method to irritate people's values and attitudes. So we aim to actually shake some of the foundations of their worldview, which, if we succeed, is an extremely emotional experience for our learners. So we are therefore faced with a classical ethical dilemma, not with the one shown here in the picture, but this is like the prototype of ethical dilemmata. But yeah, in order to achieve an ethically justifiable goal, namely that our students actually develop skills for responsible technology development, we resort to measures that can themselves be morally criticized. As our students all rated the course very positively, I myself believe this is acceptable. Nevertheless, there were demanding moments of great irritation, of frustration among our students. They said that themselves, their statements, and it was also reflected in their reflection papers. So as teachers who choose such a didactic design, we have a responsibility to accompany our students on their emotional journey. So what I've realized during the course is how important it is for students not to be left alone with these strong emotions. They needed space to express and reflect on those feelings. And the engineering students in particular experienced the moments of frustration very intensely, and at the same time found it particularly difficult to find a language to express themselves. I believe that in that situation, this interdisciplinary setting was extremely helpful for them, because they experienced that students from other disciplines spoke very openly and personally about their experience. So they acted a little bit like role models to them. And that this was welcome in the course. So I could observe how the engineering students gradually became more open and talked more personally over time and coped better with the situation. So one big realization I personally took away from this course was how important it is to prepare students for the fact that they may experience moments of frustration and helplessness, and to tell them from the start that this is actually a desirable part of the learning process. Not part of the research, but part of my insights. So with this, I would like to close because we want to have some discussion as well. Thank you very much for your attention, and hand back over to Seattle.
All right. Thank you, Ina. I think this is so interesting, and I really appreciate all of the thought that's gone into setting up a coherency between the different aspects. I'm going to give you an opportunity to ask Ina some direct questions, but I'd like to take advantage of us actually being temporarily co-located here online at the same time to give you an opportunity to talk a little bit more. So Ina, I'm just going to ask you one brief question, which is really practical. How many students were in the course this year?
This year there were less, I believe, because this year I didn't do the class. I created a new one. This year, I believe it was something about 12. Yeah, so they were fewer because you cannot do this with massive courses. It's yeah, you need a lot of accompanied students very closely.
That makes sense to me. Okay, so I am going to, so yes, I know these are not in presenter mode, but I'm going to share the slides here. So I'm going to invite you into breakout rooms for about 8 minutes here with a couple of other people. And I'd like you to talk about, like, what are your thoughts about incorporating irritation or discomfort into your own personal teaching? Is this something that you think would be beneficial, problematic? How would it be received? What are the barriers or opportunities that you see there? And if you've got through that one, then how would you do it personally? So Alexandra, if you would allow people to join breakout rooms, you're going to have about 8 minutes here to actually get to have a bit of a conversation. Apparently you will move there in the next 10 seconds, and then we'll come back in 8 minutes for a broader discussion together. If you have questions for Ina, I'm going to suggest that you raise your little hand, little purple hand here in the middle of the screen, so that Ina can answer questions, or if you've got other feedback or things to share. So Ina, I think you can manage this. I think it's easiest if you facilitate this directly. It looks like Ravi has the first question for you.
Okay, I try because I only see all of you people on 4 different pages. Okay, let's go first with Ravi.
Yeah. The issue here is non-engineers are trying to find out how engineers behave. That is one issue I am irritated with.
That's good. Irritation is good.
Second thing is, when I go to classroom, I try to be as friendly as possible with my students. I'm going to show them what are right attitudes, right behavior, right competencies for engineering students. By seeing me, they are going to remove these irritations and attitudes which are not right. Engineers, we never measure these irritating, discomforting things, but our behavior in the classroom, our behavior in the field makes the students overcome these irritations and discomforts. So I'm not sure, because the number of students are only 12, the sample students. So I don't know whether whatever the results you have shown will hold good for all engineering or most of the countries, etc. Please comment on.
All right, I'll try. First, probably the small sample size. That is true. It is small. It grows year after year because we offer this course again. And I hope at some point we will have quite a big sample size. There's always a cultural bias in there, of course. Teaching works differently at different places and with different constellations of students. However, it is based on theory. So we didn't make it all up. It's based on psychological, on social psychological theory, on educational theory. And what we tried was to test something in an experiment with quite some effort to see, does this work? And it seems to work. But of course, further research is certainly needed, and also adaptations of the concept and the course design. So yeah, I that's all I can say to that. It is a small sample size for sure. Yeah.
Thank you, Ina. Shall we move to Paul? Or do you have, sorry, do you have
I think there were 3 questions actually.
Okay.
So non-engineers researching, try to be quick. Non-engineers researching engineers. This is actually an advantage. I'm a social anthropologist as well. I myself did research in India, and I had a Pakistani professor doing research in Germany as a sparring partner, which was beautiful because I learned so much about my own culture by him looking at my culture, and the other way around. Because if you're part of it, it's hard to see. It's actually a good thing, and we ourselves were interdisciplinary as well as a team. And at least I've been working with or among engineers for 12 years, so I was not a complete stranger to that. Okay, but I guess I have to move on.
Thank you. Thank you.
Yeah. Sorry, I think it wasn't all, but yeah. Paul was next in line, I think.
Yeah, thank you. Well, thank you very much for your presentation. It was so interesting. I had a question related to cultural diversity. So it really kind of follows on a little bit from what Ravi was sharing, which is that how do you think things would work? Because I imagine that all of the students that you had were German students, or not necessarily.
They were not all German students,
German.
no. Not
Okay,
all of
because
them.
I was wondering if, for example, you did the same experiment, and you had a group of German students, and they maybe did a project, maybe with Indian students, or I don't know, or Spanish students, for example. What kind of maybe additional irritations would you sort of consider within, because engineers need to work within a sort of multinational context. They can maybe have to do that in their in their future career. I just wondered what your thoughts were on that, or would that be far too complex?
No, that's perfect. We do this in other classes. We have European-wide courses where people come for 1 week to Berlin, and we all do a starting class together, and then they work remotely in their teams.
Okay.
And they come even from even further away, Morocco and wherever. And our experience, the more diverse the group, the better the learning results, both on the engineering conceptual level and on the competency development. It is more challenging, and you need to accompany them even more closely. But yeah, it's a very good to mix as broadly as possible.
Yeah. Thank you very much. Thank you.
So I think next one, yeah.
Tina, we can see that you're speaking, but you're on mute.
Sorry. Yes, I was like, where is that mute button? Okay. Yeah, so thank you. So I just have a quick question about the paper title. Because I would love to read more about it. Or will that be, where can I?
The paper, the SEFI paper?
Yeah, it's okay. Yeah, I would love to have the paper title.
What we did, we described in the last SEFI conference, and the proceedings are not out yet.
Oh, okay.
But it's in, I mean, I can share my slides. I probably, yeah, you could, I don't know, pass them around. And in there, it is already mentioned as a source.
Okay, yeah, thank you. Because I'm actually writing a paper on how, similar like how we can move away from the neoliberal paradigm of education, and this is really a big source of inspiration, like what you've been talking about. And also, there's it reminds me of another paper where researchers have looked at how the stereotypical view of people in academia of what discipline requires the most excellence. And of course, physics, and that would be like the discipline that people think requires the most excellence, while education is like the least excellence required. And then one of the recommendations there was actually to do these kind of courses, interdisciplinary courses, to help to remove these sort of thinkings. And that's why I think it's a great course that you have like created there.
Yeah, thank you very much. Yeah, and we are certainly not the only ones doing that kind of stuff. There are many other universities doing very similar things, but I think it's wonderful that we are having this this new direction that university teaching is going to. Yeah. So.
And I just want to thank Tina Furman so much. Oh, and Emanuela has also beaten me there to actually have the link to the Zenodo repository. So the SEFI paper 2025 papers are now available.
Are they?
Yes. Oh, sorry, the 2024, sorry, not 2025. Yes, the SEFI 2024 papers are available. Wouldn't it be great if the 2025 papers were there and you could just go and download your own paper? Not yet. Mircea, you have the next question.
Yes, thank you. And thank you, Ina, for your great presentation. Yeah, I teach philosophy to a large group of engineering students. So my question is simple. How do you scale up your, let's say, experiment? Can it be, is there hope for doing something like that on a larger scale? Because it's hard to sell my philosophy courses for just a handful of students. Okay.
Yeah.
Thank you.
We actually plan to scale up. You know, most of the work the students do by themselves. So the most of the work is this going through the conflicts, going through the contradictions, finding their solutions. So once you know how to present your input, the main thing you do is actually be there for them and for their questions and for their doubts. And this, of course, depends on how many students you have. So if you have like 40 students or 100 or 300 makes a big difference, because at latest, when they start going into the transdisciplinary collaboration, they will have lots of questions and lots of doubts, and they will all write emails to you. And this is then a matter of classroom management, I guess, that you give enough space during class for discussion and discussing those, expressing those emotions and expressing those doubts, and probably go rather into some kind of peer feedback system, which we also did a lot. So every second class was actually peer feedback, and this takes some of the effort from the teacher, which I think is necessary if you go into massive courses. Yeah.
Thank you very much.
So are there any, so we are over time now. So I'm just going to say that we'll do another webinar in this series in February, as soon as I get a confirmed title and date. But if you have other proposals of either your own work or other researchers that you think fit well into the series about discomfort and uncertainty and the opportunity that they create for learning, please let me know. Put your own hand up if you're interested. We'll have, I think, about another 4 months that we'll try and run in this series. Thank you, Ina, so much for this presentation. I think it is very exciting in many different ways, both in terms of the pedagogical principles that you've used about setting up your work, about the breadth of the different ways that you've implemented that, and the way that you're documenting it. I think is really, really interesting and really exciting opportunities that you're creating in a really thoughtful way. So thank you so much for taking the time to share that with us again today. I don't have to run off anywhere. I understand that many people may have something right afterwards. So if you've got to go, thank you so much for being with us here now. I hope to see you again next month. And if you don't need to run away, please stay for a minute and share your thoughts about irritation or uncertainty in your teaching, or if you've got any other questions that you want to ask Ina, please stick around. Thank you.
Thank you very much.
And thank you, Ina.
Thank you.
Thank you.